Hello friends, in the previous class we have discussed about the equivalent circuit of a JFET, it is small signal equivalent circuit. We'll continue the topic, that is the frequency limitation factors. So in today's class we will discuss frequency limitation factors and cutoff frequency. So there are two frequency limitation factors in a JFET. Namely, the first one is the transit time and the second one is capacitance charging time. The first one is channel transit time. If we assume a channel length of 1 micrometer and assume carriers are traveling at their saturation velocity. So first let us assume a channel length L, which is of 1 micrometer, and assume that carriers are traveling at their saturation velocity Vs. Then the transit time tau t is in the order of tau t equal to L by Vs, that is equal to 1 into 10 to the power minus 4 divided by 1 into 10 to the power 7. So if you calculate this, you'll get 10 picoseconds. So the channel transit time is the limiting factor in very high frequency devices. Remember here, the channel transit time is the limiting factor in very high frequency devices. Now let us consider the second one, the capacitance charging time. The figure shows a small signal equivalent circuit with capacitance. So the second frequency limitation factor is the capacitance charging time, and this figure is a small signal equivalent circuit with capacitance. This figure is a simplified equivalent circuit that includes the primary capacitance and the diffusion resistance that are ignored here. Here in this equivalent circuit that includes the primary capacitance and the diffusion resistances are ignored, the output will be the short circuit current. The output will be the short circuit current, as the frequency of the input signal voltage VGS, observe at the input side, at the frequency of the input signal voltage VGS increases, the impedance of CGD and CGS decreases. So the current through CGD will increase. So what happens here? As the frequency of the input signal voltage VGS increases, the impedance of CGD and CGS decreases. So the current through CGD will increase. For the constant GM VGS, the IDS current will decrease afterwards. The output current then becomes a function of a frequency. The output current will be the function of a frequency. Now if the capacitance charging time is the limiting factor, if we consider the second type, that is the capacitance charging time, if it is a limiting factor, then the cutoff frequency is denoted by Ft. The cutoff frequency Ft is defined as it is the frequency at which the magnitude of the input current II is equal to the magnitude of the ideal output current GMVGS of the intrinsic transistor. That is, the definition of the cutoff frequency FT is the frequency at which the magnitude of the input current II, which is equal to the magnitude of the ideal output current GMVGS of the intrinsic transistor. Now when the output is short circuited, the input current II is equal to J omega into CGS plus CGD into VGS. This is equation number 1. Input current II equal to J omega into CGS plus CGD into VGS. Now if we let CG equal to CGS plus CGD, then at a cutoff frequency, the magnitude of II, modulus of II is equal to, as we know, the omega is nothing but 2 pi f. Here f is nothing but a cutoff frequency, that is Ft. So magnitude of II equal to 2 pi Ft into CGS plus CGD is nothing but CG, that's why CG, and VGS as it is. Now that is equal to GM into VGS. Or else you can write FT equal to GM by 2 pi CG. The maximum possible transconductance is GMS max. It is also denoted as G01, that is equal to E into mu n into Nd divided by W into A divided by L. And the minimum gate capacitance is CG minimum is equal to epsilon S W into L by A, where A is the maximum space charge width. The maximum cutoff frequency can be written as Ft is equal to E into mu n Nd into A square divided by 2 pi epsilon S into L square. Now let us see a problem. Calculate the cutoff frequency of a silicon JFET with the following parameters. The parameters are given: mu n is equal to 1000 centimeter square per Vs, A is equal to 0.6 micrometer, Nd equal to 10 to the power 16 centimeter per cube, L equal to 5 micrometer. So observe the given things. Mu n, A, Nd and L are given. You need to calculate the cutoff frequency. Cutoff frequency Ft is given by E into mu n Nd into A square divided by 2 pi epsilon S L square. Substitute the given values. We know that electronic charge E is nothing but it is 1.6 into 10 to the power 19. Mu n is given, Nd is given, A is given, 2 pi as it is. Epsilon S value is 8 into 8, 5 into 10 to the power minus 14. L is given 5 micrometer. So calculate all the values, substitute all the values and calculate. So 1.6 into 10 to the power minus 19 into 1000 into 10 to the power 16 into 0.6 into 10 to the power minus 4 square, 2 pi 11.7 into 8.85 into 10 to the power minus 14, 5 into 10 to the 5 into 10 to the power minus 4 square. So if you calculate this, you'll get 3.54 gigahertz. This is the required cutoff frequency of a silicon JFET. Thank you for watching the video.